In this video, we're going to be learning how to make a truncated counter, or a counter that doesn't just go forward and reversed from whatever 0 to whatever number of bits it has. We're going to learn how to make it start at a very specific number and end at a very specific number. Here you can see I have a counter. If you haven't seen the video on just regular binary counters that's on the channel, you should watch that one first probably to make sure you understand those. So here I have a counter that's counting forward. It's D flip-flops. The JK counters are very similar, but this one's just less wires. So I wanted to keep it simple to show you how to truncate it or to make it start and stop at a different number. So this one's counting forward. On the graph on the right, you see the pattern that it's creating. To simplify things a bit so we don't worry so much, I'm going to actually remove the clock digital probe so that we only see the place values instead of seeing the clock as well. So this counter is counting forward or up from 0 as it is now, and then it starts going to 1, and then it goes to 2, and it keeps going. So how do I make it so that I stop it at a very specific number and start it at another very specific number? Let's start with setting the start limit. One of the things that you should realize is that I can activate the overrides, the top set and the bottom reset, to force it to be all zeros or to be all one. For example, if I put a switch, doesn't matter, I'm gonna call this override. Override. So my override switch, what I'm gonna do, I'm gonna start by forcing everything on the resets. I'm gonna remove the ground. So now it's not always deactivated. It's actually going to be activated by this switch for now. So all the resets on these flip-flops activate with a 1 or a high, because as you can see, it's just active high. Now there are others that have inverters on there and those would work in reverse, but let's keep it simple for now. And then notice that whenever, if I have the switch set to 1, all these would reset to 0. So for the moment, let me turn it off to 0 and let's see what happens with our counter as we are. I'm gonna, as you can see what's happening on the right-hand side on the plotter, but I really want you to focus on what's happening here with my counter. Okay, so as I press play or start the simulation, my counter is gonna be counting. It's gonna go to a 1, then it's gonna go to a 2, and I purposely left it a little bit slow so that you see the behavior. Now we're at 3. And the moment I press this override, no matter what state of the counter it's at, it's going to force all the flip-flops to go to 0. You see that? So immediately when I pressed it, all my flip-flops went to 0. If I release that override, the clock takes over again. See the clock right now, I don't know if you can see it, the clock is blinking on and off. And it is telling the counter to count, but the override is active, so it's not letting it because they're all forced to reset. If I release that override, then the clock takes over again and my counter continues counting starting from 0, 1, 2, 3, etc. Okay, so by overriding the resets, it forces everything to be 0. Now, let's say I don't do that. I'm going to press Ctrl-Z several times to take that out. Okay, let's say I actually override the top side, the sets. I'm going to delete these. And I am going to connect all these overrides to a 1. Oh, there. So these overrides, these sets are all going to be controlled by this switch. So what do you think is going to happen? When I press play, actually, this is going a little bit too slow, so I'm going to speed it up just a bit. Again, it's not really 10 hertz, it's 10 hertz to my computer, but I have other things running, so it's running a little bit slower. Okay, so my override is not active. So when I press play, my counter is going to start counting the way that it should. 1, 2, 3, it's a little slow, 4. Now, what's going to happen is the moment I activate my override, if you said it's going to force everything to 1, you're right, because the set, when it's active, it forces the output to be on. Okay, So as you saw, if I activate the bottoms, it forces zeros. If I activate the tops, it forces ones. Well, what happens, I'm gonna undo. What happens if I mix them? So put everything back to normal. I'm gonna, I guess it doesn't matter where you put this switch, but right now I'm gonna put it over here at the bottom for now. So what I'm gonna do is I'm gonna override some of them to set and some of them to reset. So for example, I know this is my ones place. I'm going to make this one on the top, which is gonna force my circuit to turn on to a 1. This one as well. This one I'm gonna make it also force the top. So it's gonna force the 2's place to be a 1. So the 2 and the 1 are gonna turn on, and these I'm going to force to turn off. So I remove that one. So remember, this is the 8's place, the 4's. So those are gonna turn off, and 2 and the 1 is gonna turn on when I override it. So right now I'm gonna start it with off. And still, I'm thinking it's gonna be fast enough, but I can't. I changed it. What the heck? Oh, I went back to it. Make it 20. Okay. So here we go. If I press play, my counter is going to count normally forward because it's a forward counter. I'm not overriding it. So it's counting 0, 1, 2. And I've been stopping it at like 4 or 5, but it doesn't have to be. Wherever you stop it, it doesn't matter. Okay, so let's see, 7, 8, whatever. I'm going to force the override. What it does is that the override pauses, or not, yeah, it pauses the count. No, I lie. It's not pausing it. It's overriding it. It resets on some and sets on others. In this case, it sets the 1's and the 2's, so it forces a 3, and the 4's and the 8's gets reset. So that's how I force a 3. Let's say if I wanted to force the number 6, for example, I would force the 4's and the 2's to be on. So to make a 6, you can only do one or the other. You can't force a reset or a set at the same time. It has to be one or the other. So I always make sure nothing's connected. That's the 4's, the 2's, and this is the 4's. The 8's is reset, and I'm going to force my 1's place to be reset. So right now I'm going to force reset on the 8's and the 1's, and a set on the 2's and the 4's. And multi-sim allows you to leave things disconnected like this. I don't like to do that just because it's poor practice. If we're going to be breadboarding these eventually, I'm going to forget to do that if I don't do it. So if you're not using it, just disable it. Okay, so here I am going to make my counter count. I think it's going a little slow because it's plotting these so slowly. So I think that's why it's going so slow. Let me increase it again. So if I press play now, you're going to see that my counter is going to be counting forward. 1, 2, it's a little faster. So it's counting forward. Now I have, when I press the override, it's going to reset the 1's and the 8's, and it's going to show a 4 and a 2, which is a 6. So as you can see here, let's go, let's wait until it's got something on there. There you go. Turned it on and it overrode to 6. Okay, so that's how you set the starting limit of any counter, by setting the sets and resets to the number you want to start at. But then how do you continue going and how do you end it? Well, for that, you're going to need some combinational logic. So for now, let's forget about this override. How do I, yeah, let's actually, what I'm going to do is I'm going to set it to 0 just to keep it simpler. So I'm going to connect the overrides to 0 just to go back to at that place. So, okay, so here I have all my overrides to reset. The top ones, I'm not going to use it, and I'm going to connect them to disable them. Okay, so let's start from there. So right now my starting limit is 0. So when I press play, since my switch is active to a 1, it's a 0. If I stop overriding it, it will continue counting forward. Okay, so that's how you set the starting limit, but I'm going to replace the switch in a second with the logic that's going to stop it. So the ending limit, what we're going to do is we're going to use logic that tells me, okay, when it's, for example, in this case, a 5, right? A 4 and a 1. So when the 4s and the 1s plays are on and the 8s and the 2s plays are off, I want at that point to tell all the flip-flops to go back and start at 0. So there's lots of logic you could use, but the simplest one is just AND logic. So I'm going to use AND logic, and since I have 4 things that I want to AND together, you could just AND the 1s and the 4s, but it depends on the number that you're at. You're going to need to check that the 2 is off as well. So it's always a good practice to just check all the bits rather than just the ones that you want on. So again, don't check only the bits that you want on, check the bits that you want on as well as the one that you want off. So to check that I want it to be on, so here I would say, okay, I'm gonna stop it at a 5. So when the 1's place is a 1 and the 2's place is a 0, well, the AND gate needs a 1. So what I need to do is put an inverter here or connect it to the NOT queue. To keep it simple, I don't want to make it so confusing. What I'm going to do is I'm going to put an inverter here just to make it really obvious that I want the opposite. So I connect an inverter right here. What's going to happen is when the 1's place is on, the AND gate is going to receive a 1. Remember, the AND gate needs all the inputs to be 1 for the output to be 1. When the 2's place is a 0, this inverter will make sure the AND gate gets a 1. If I didn't have the inverter, the AND gate wouldn't get the 1 it needs. When the next place, which is my 4's place, is a 1, I connect it to the AND gate as a 1. And I want to check when the 8's place is a 0. Oh, it's a little bit out of order here. I'll clean it in a second. When the 8's place is a 0, that means we need an inverter, so the AND gate gets a 1. Okay, so let me make sure I did it correctly. Okay, so here we go. When the 1's is a 1 and the 2's is not a 1 and the 4's is a 1 and the 8's is not a 1, this AND gate will give me a 1 output, which I replace the switch with. So here we go. You just connect it like this. What's going to happen is when my logic shows a 5 in binary, as it does now, the AND gate is going to say, no, 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 don't show the 5, override it with a 0, 0, 0, 0. Let me show you, but this time I do need to slow it down a little bit because it's going to go pretty fast and I need you to see that it doesn't really show the 5. Maybe, I don't know, I keep playing with the speed and the computer decides to go slower. Okay, so here we start with a 0. It's going to count forward. As you can see, it's a 1, then it's a 2. Now remember, the moment it reaches 5, it's going to overwrite to 0. Do you see that? Do you see this little spike right here? Let me show you on the graph. It was going to be 5. Here, 3. I'm going to stop the simulation. So let's start from the beginning. Here we go. So we start at 0, 0, 0. Then it goes 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, which is a 3, 0, 1, 0, 0, which is a 4. So it showed the 4. And then it was a 5 for a fraction of a second. Do you see that? Let me see if I can zoom in here. It was a 5 for a fraction of a second. Right there. Do you see it was 0, 0, 1, 0, 1, And then the AND gate said, don't show a 5 anymore. Go back to 0. So it went back to 0, 0, 0, 0. Got it. So the number that you put here gets erased by the new starting limit. So again, you should look at it a little slower. So here it's a 0, and a 1, 2, 3, 4. It's going to be 5 for a fraction of a second, and then goes to 0. So that one doesn't really count for our eyeballs. There's other counters that you can make if you want to get rid of that little spike. But for the most simple counters like these ripple counters, that's not a problem. So let's modify this counter to count from a different starting number. So down here, this down here, oh, wait, what did I get? I meant to get a text box. So this down here is my starting limit. So set starting limit with set or reset overrides. That's how you set the starting limit. It depends what you connect it to. And then the other thing you need to see is the ending limit right here. We're gonna set the ending limit with, I'm gonna say 1 after with the AND gate. Okay. So for example, if I wanted to go, let's say I wanted to go from 1 to 9. Okay, so 1 to 9, I would have to end at 10 because I have to end 1 after, right? So 10 would be an 8. So I need to get rid of that inverter. So it would be an 8's place. So that's an 8 and a 2. Oh, exactly backwards from what I had it. So not the 4, not the 1, and I need to take that one out. Okay, so 8 and 2. Let me check that again. So a 10, I want to make it count from 1 to 10. So that would be not the 1s, yes the 2s, not the 4s, yes the 8. So the 8s and the 2, that's 10, so it's going to count up to 9. Okay, then I'm saying things and I'm changing my mind, so I apologize. Let me say forward counter that's going to count from 1 to 9. Okay, so that's what I want to make. So the ending limit is going to be set 1 after, which is a 10, which is the 8 and the 2, not the 4s and not the 1s. And then if I want to start at 1, I force reset on all of them except the 1's place. On the 1's place, I have to force it to be a 1. You're gonna hear all the announcements. Okay, so at this point, if I press play, we're going to be seeing the counting sequence. Seven, 8, 9, and it starts back at 1 because that's what we set to the starting limit. So again, the ending limit, we set 1 after the ending limit that we want with the AND gate, putting the inverters on the 0s and no inverters on the 1s. And then the overrides, we set the number that we want. For example, let's modify this one, only the starting limit. So let's say we wanted to go from 5 to 9. Okay, so a 5 would be a 4 and a 1. So the 1 is already set, and I would have to include the 4's place on my starting limit. And the ones that I'm not used, I'm just disabling them. So if I press play now, when you first start a simulation, it's always going to start from 0. So you're going to have to wait until it reaches the 9. The 10 will get replaced with the 5, and then it's going to stay stuck in that loop. As you can see here. So now it's 7, 8, 9, and the 10 gets replaced with a 5, and then it continues. 6, 7, 8, 9, 10 gets replaced with a 5. You can see here on the right the graph for how the bits are on for a second or off for a second, and then they get replaced. So there you have it. That's how you make a counter count from a starting limit to an ending limit. The starting limit is going to be by the override, set, and reset, and the ending limit is going to be set by the AND gate. One thing to notice is that if you're counting in reverse, your ending limit, if you're counting in reverse, let's say from 10 down to 2, the ending limit is going to be a 1 because 1 is after 2 counting down. That's it. So that is truncated counters, counting in this case from forward from 5 to 9. You set the ending limit and the starting limit. Thank you.